Okay. Hello, non existent audience. This is Halfwiredtv. Halfwiredtv is a community of robotic enthusiasts. Ignore the dog behind. Ignore the dog behind me. Yeah. So, Halfwiredtv is a community of robotics enthusiasts that are just interested in robotics. They have something interesting to contribute, regardless of their skill level. And these people collaborate with each other continuously. They learn together, grow together, they live stream their learnings and their projects they're working on, similar to Minecraft servers. And yes, we are not professionals. We are we aren't all working professionals who happen to design crazy robots on day one. No, this is supposed to be a place where 100 dumb people just start growing together slowly but surely. And in the last 12 days, we have managed to grow the community from zero to more than 120 international robotics enthusiasts from 13 plus countries now, and it's still increasing. I haven't been able to keep count of exactly how many we are right now, but it's surely a fuckload. And yeah, if you do want to join, if you do want to share something, if you do want to have your voice heard, if you do want to, speak out on a platform, this is it. Or if you just want to see people suffer and just like seeing people in pain, then yeah, again, this is it. We'll be starting very shortly. uh, our current challenge that's ongoing is speed running through SolidWorks. And yes, I did learn a bit of SolidWorks, but I kind of forgot to stream. Yeah, that's the only reason. I did do one stream where like I started from the absolute zero, but the crowd with me was practically dead. I don't know what is with these what is it with some people. Like, I know they were from India and it was pretty early in the morning, so maybe they didn't want to wake anyone up. But then why join the call in the first place if you don't want to speak anything? But regardless, uh, later I did get accompanied with Tanya, which ha- he has become, like, honestly a really good friend in such a short amount of time. Just a crazy guy who reads research papers for fun, analyzes them. He's working on some crazy shit. And yes, some of our interests do overlap. And what do you mean? You both are robotics enthusiasts. Duh. No, robotics is a really, really, really fucking vast field where all the way from micro robots to robot swarms to military drones, we literally have everything. The thing that I am specifically interested the most about is bio-inspired robotics and space robotics, or maybe bio-inspired space robotics as well. And what do you mean by that? Well, is my screen sharing? It would be really embarrassing if my screen isn't sharing right now. Oh, it is sharing. Nice. Okay. So, there's a company called Festo who makes bio-inspired robots. What are bio-inspired robots? Fucking robotic kangaroos and robotic flying foxes, robotic. I was about to say Dragon Ball Z, dragonflies, and the one I'm most passionate about, robotic spiders. They just look so cool. They look out of a sci-fi movie. Imagine like a small spider robot friend that you could just call it in, like you should just wave your hand and it just comes crawling at you. It stays by your side, it helps you with stuff. I do want to build something like that one day and just name it something cute like Zorro. Well, I guess the only thing that's left right now is just speed running through it. We'll see if we'll be joined by other people. Uh, I do doubt that we'll be accompanied by many people today, is because I'm on vacations, obviously, so I don't care. But other people are like, most of the people are 9.5 hours behind me. So they are at like 7 p.m. right now, and 7 p.m. on a Monday. So they are likely just finishing their work.
Hey, who are you
Yo,
speaking to?
I was speaking to the non-existent audience.
Oh, really? I was wondering if someone was there.
Oh, yes, Sandeep was speaking to a ghost. Why is he speaking to himself?
Yeah, no, I mean, I got confused for a minute. But yeah, I mean, I just, I mean, I got home like an hour ago, but I kind of needed to do some
Chill a
things
bit.
around my place. Sorry?
I thought you needed to like relax a bit after a work day.
Uh, it's fine. It's just food and fine. I'm kind of used to
Suffering.
jumping straight to work, you know,
Damn,
after
bro.
a work day. I've kind of been doing it for a couple weeks slash months now. So yeah, yeah. I just read your question about what I did for like toy simulation.
Yeah.
I guess my guess is like he has a generic message, right, that he sends to anybody that he thinks could be a candidate.
Hmm.
So I don't think that message was like customized for me. Maybe he just changed the paper name or something like that. But that's also his recent paper. So he just sent it out, okay, do a simulation on either MATLAB or Python based on what you want to do.
Hmm.
So for me, his own paper is like a sensor placement. So um, how much can you optimize what you have to be able to place sensors for best detection and overall best performance basically. So like what are all the optimization algorithms that you could use? So he goes into that, and then he shows how you could do by transforming lines into points by Poisson processes, that you could have like some derivations and be able to have the best placement by a greedy algorithm um, in a certain area. So my contribution was going to be, well, you are assuming that the sensor is performing at its best capacity. So I want
Hmm.
to make it a bit more realistic by removing that assumption that, okay, if you said, so in the paper, I think I said last time, they assume that, oh, the sensor is always at 95% of its capacity.
Yeah.
So it's always performing at its somewhat best capacity. So I want to remove that assumption and introduce some variance. That would mean that then you're not sure, and which is better for you because you have a margin, right? So you are allowing your sensor to even have a margin of, oh, what if it starts to perform bad? I can still achieve good results. So in a couple words, that is like my uh, extension, like my idea that I want to add to his work. So how do I do simulation of that? To be fair, it doesn't need to go into like a 3D robotic simulation. This is purely an optimization problem, and it because it's a one-time placement. So I just compute all the formulas that I had into
Hmm.
a Python script, and I just run it and then try to plot the results and compare the results with what he did in his paper.
Oh, like so you don't even render any
So,
visuals, just find out the final value of the parameter.
well, the visuals are like the graph. So I plotted a couple of graphs. For
Hmm.
example, the exact sensor placement. So I can actually go through it.
Oh yeah, you
I
did a.
definitely,
Hmm.
sorry.
Like I do remember, like the first you had like a graph which showed like the most
Yeah,
popular parts of the ships,
yeah, yeah.
and
So
using
that
that,
that's from the paper. That's from the
yeah.
paper.
And wait, so did in your extension, do you also assume that the path will change?
No, so this is like public data. Like they're using historical data. So I'm not touching the part there. So it's if you do the idea is that if I do how do you call it, for this group, then I'll
Hmm.
be able, like, this is applicable to any um like part that you can get,
Yeah.
because you don't, you just take it as a part. It goes through the same transform. That's what I'm trying to say.
Hmm.
So it goes through the same equations and formulas. So
Hmm.
I can actually put the papers side by side with that. Um, Hold on, I'm trying to pull up the paper. Blah, blah, blah. Yes. Uh, well, this is what I was showing last time from the paper. I believe what you remembering is this,
Yeah.
right? What you were listening to, yeah. So this is like the part. So I'm not touching this part, right? So I'm just going with the same assumption that, oh, we're gonna assume. Actually, for me, I even go very simple. I just assume like a box like that because
Hmm.
this is not the main focus, and it's gonna go through the same formulas, right? So this is density and all of that. Now, the computation of the sensor placement, uh, it's according. So when you see like um, this graph with density, like the sensors can see how the sensors are placed according to that density to be able to cover everything. So that's kind of it. I would not say I reproduced exactly what they did, but like the concept of it, I think I did. Now it's gonna be up to him to say if he thinks the same. So my
Yeah.
first output um, is this. So using his own algorithm, so I used the intensity that was I used intensity that was provided in the paper, not the values though, right? But yeah. So my first output is that even when I introduce my uncertainty that okay, we don't know whether the sensor is performing at its best capacity or not, I'm still achieving the same result as the baseline, right? So that is the first result, my first observation. This would alone doesn't tell much of the story, but when you go to the second one, then it shows a certain distribution. So meaning that for any deviation in the value of the sensor capability, for my method, which is in orange, you are still staying within that close range of
Hmm.
probability. And for the baseline, which is the paper, you have a wider distribution. So like you you're not sure. So your probability becomes even less obvious. So the concept here is that the smaller the distribution, so the less the uncertainty, if I can call it like that. So yeah, that is the main thing that I want to make my case on that. Okay, this can actually achieve a better result if we introduce this. We introduce the uncertainty instead of assuming the capability.
Yeah.
The third one is it's called, yeah, basically the same as the previous, but just plotted as a line. So yeah, so this is like okay, not the same one. The other one is like distribution, but this one is according to how much the uncertainty grows. So the more uncertainty you have, the more the baseline decreases in probability, which is not um, optimal.
Hmm.
So I am showing that my approach, even with some level of uncertainty, you are staying stable. To an extent, you are staying at a stable probability. So void probability is basically the probability that um, nothing is being missed. The sensor doesn't miss any ship. So basically showing that okay, my approach is quite stable if we introduce uncertainty. Uh, well, this is like the summary and everything. Uh, yeah, everything that I just explained, it's summarized in this document.
Hmm.
Um, yeah, so that's kind of it. To be fair, I had to really go and learn some of the concept. I'm not gonna lie. I had to go. for this book, which I could only find some chapters online. I couldn't even find the full version. Uh, but yeah,
CM Bishop.
yeah. But then the thing is, I found just what I needed, right? I needed those
Yeah.
chapters 2 and 3, so I didn't really look for the full book. But it's yeah, pretty interesting. Um, but yeah, that's it. Now I've been trying, like, I'm doing this exercise of trying to explain it myself, just to make sure that I understand it to a level that I can explain. So did you think I explained it? Like, what did you think of my explanation?
Well, I would say yes, like on an intuitive level, you explained really well. And of course, for me, someone who like did not read through the entire paper and learn all
Mm-hmm.
of those concepts. So
Mm-hmm.
yes, some of the
Mm-hmm.
things just seem like a magical black box that just work somehow. But yeah, the
Mm.
intuition was great mostly.
Yeah, I mean, obviously, is definitely not a black box. Like, if, yeah, I would obviously have to dig deep into like the specific formulas that I use, the
Yeah,
derivations. But then again, I mean,
that would
in
get
for
too
our
deep, right?
conver yeah, for our conversation, I don't know if I should be doing that. So I tried to keep it like high level, so
Yeah.
at least you can understand what was my end goal and what I achieved as a result. So yeah,
I
I
guess
think
that's
this
just
too
my
was
curiosity picking out. Most people would be
yeah,
satisfied with that explanation.
yeah, yeah. Oh yeah, this is a good thing. It is a good thing. Uh, I'm glad you asked, because that gives me the opportunity to um, explain.
Yeah.
So now I don't know. It's gonna be up to him. I really am. I don't know. I have mixed feelings about whether he's gonna like it or not. Um, but it's the quality of this work is gonna depend on whatever he responds. So let's see.
I mean, I
I
don't.
would like to have a chat with him,
Hmm.
but
Sorry.
obviously, sorry. No, I said, well, let's see if I can get even like a chat with him, or like
Hmm.
basically that would be him interviewing me, but in a different context. So yeah, yeah. Speaking of interview, yeah, I was able to. I mean, I don't know how much of help that was, but I was able to get in touch with my friend at Nvidia. I was like, oh, so like for the Justin guy.
Yeah.
So I was like, well, I have a friend that has an interview. So do you have any tips? I was like, well, he said just prepare for problems. Look online for people who have applied for this job. Um, Pretty generic stuff, but always good to know that this is actually what gets people hired.
Hmm. I did not think that even in robotics we would have to go through the DSA shit.
Well, it's everywhere.
Ah,
I think I think yeah, I think it's everywhere. Even
it's
I thought you could escape it, but nah. I guess like the high paying jobs, like you have to.
hmm.
For
I
example, like
mean,
for me, I think no, yeah. What did you say?
I was saying that like maybe because he is applying as a tensor something engineer and they would likely like work with visual stuff. So maybe that's why he needs
Yeah.
graphs, and he specifically mentioned graphs.
Yep. Well, this will be the stack they will be working on, I guess. Yeah, it says a lot of machine learning, optimization, graphs, like you said. Yep.
I really plan to complete like at least 50% of what I would deem is sufficient DSA for robotics. But then honestly, it's so mind
50,
numbing.
50% of what?
50% of what I would deem as like sufficient DSA for robotics, because like I just skimmed through DSA for my
Mm,
coursework and I did not really pay much attention to it.
mm,
I thought I could
I
do
see.
it, but it's so boring. Instead, I picked up kinematics and SolidWorks and those sort of things.
Mm, I get it. I see. Well, what is okay? I guess what is your um? Do you have target roles?
Uh, I'm not sure if I have a particular target role. Like a lot of people have like, target roles like robotic
Mm,
design engineer and robotic simulation engineer.
mhm.
I'm not quite sure. Like from a job
I mean,
perspective,
yeah.
simulation role
I
may
mean,
hmm,
yeah. Of course, for you, it's like it's pretty early, right?
yeah.
I think you have a lot of time to figure out. I mean,
Yeah, currently it's like I
there's
like every part of the robot. I want to make everything, but that's not possible in a job setting, is it?
yeah, it's not. It's definitely not. Like for example, for me, yes, I think the designing is pretty cool, but I most likely would not lean towards there.
Yeah.
Um, I will definitely participate. But like usually, I set up like LinkedIn alerts just to keep up with the skills that people need.
Hmm.
This is one of my target roles. Over 100 people. It's always like that. And
Reposted 2 days ago.
my main target role, I think, embodied AI. I think if I do everything that I want to do, this is the type of work that I want to be doing. Embodied AI, robotics, and then the interception of that with um, multi-agent robots, prediction and planning, like yeah, joint prediction and planning.
You wanna build an army of AI robots.
Well, why not?
Everything that sci-fi movies have warned us about.
Well, it
It would
is
be
here
pretty cool though.
already. Yeah.
I do wanna put an embedded AI in a spider robot, like a companion. He would just crawl up to you randomly and it would help you out in random scenarios. That what my plan is.
Right,
But
right,
that's like
right.
For the very far future.
Yeah. Yeah, that's not a bad thing. Um, but yeah, I mean, if I guess if you have like target roles, that always help because like one thing I do, I always try to see what are the roles that they usually want. And I actually, at least this one I have, this is the job I'm trying to run away from. Well, this
Test
I have.
management.
This is the job I'm trying to run away from.
I don't even know what test management means.
It's pretty easy. It's just like a big platform when you have to track or like your sprints, software releases, and then you as a test engineer, you'll be responsible for creating test cases, running your automations, basically staying on top, doing your regression testing, doing
Hmm.
your stability testing. It's pretty fun, but to be honest, it's not for me, especially if it's only that job. See, this job, for example, it is deployment and testing. I can do that,
Ah,
but
not all day.
testing alone, sorry?
Like you could do that, but not for like 6 months at a time, just making test cases all day.
Exactly, exactly. So yeah, it's pretty tiring. Well, so I've definitely been thinking about making like a roadmap for my target roles. So, like how you put like a roadmap for how do you call it, ROS and all of that.
Yeah.
Yeah, I was definitely planning. I was brainstorming earlier today. That's it right here. Why is my conversation not loading? So definitely I'm gonna go through maybe like not really months, but I don't know why it's giving me month by month, but in this out of I'm gonna go through optimization. I think linear algebra, I already have the basics. Optimization, yes, but I would go over it again. Graph theory, I'm not very good at that. Multi-robot task allocation, yes. Search algorithms, yes. Probability estimation, this is where the hardest problems are, I guess. And then deep learning. I mean, I definitely have the foundations, but it's always good to brush up. So that's kind of my goal, to go over stuff like that. I was thinking I was gonna try and kick one or two problems every day and document that on Git. That was gonna be my plan today. Hey, don't you think we should like advance on that design?
SolidWorks?
Yeah.
Yeah, we should.
Oh,
I do have that open in another window.
yeah. because I think it was pretty interesting to go through though.
Yeah, I'll go through the Helix tutorial once more just to digest everything I learned yesterday, and then I'll proceed to assembly.
Yeah, I mean, you went to the Helix. I just stopped at this one, to be honest.
L bracket.
Oh, the Helix is the next one. Okay,
Yeah,
well,
I mean you
but I
could
still
catch
have
up
to do
pretty
the,
fast. It's not
yeah. Yeah,
the UI has
yeah,
changed a little bit, but it's mostly the same.
yeah. No,
Uh,
I don't have big issues with the UI on this one. To be fair,
yeah, the one thing
it's
I
pretty
found
it's
a bit irritating was that when you poke holes in your like the model, it doesn't
yeah.
show you a preview of how the hole will look. You will have to click around and find out. That's weird
Oh,
for
really?
me.
Let me try that. I'm pretty sure it's on the features. Yeah.
Surface of the bracket.
Oh, my bad.
And script type sectors that used to mount to the frame of the robot. Let's continue with the L bracket. The L bracket requires two holes, which you can use to mount to the frame of the robot. Select the hole wizard in the Features tab to create holes for standard screws. On the left side of the screen, in the Hole Type section, select Hole. Make sure you have ISO for standard and screw clearances for type. Then set the size to M6 and the end condition to through all.
Screw hole. Yeah, probably that one. Yeah. The size M6.
To identify the locations of the two holes, go to the Positions tab and select the top surface of the bracket. Top surface of the bracket. Now click into approximate locations as shown and click the green check mark. Notice that under this feature you
Yeah, that's what I was talking about. Like
Oh, okay.
the preview only gets visible once you click on it.
I see.
Uh, 3D. And by the way, you selected M4. Yeah.
Pretty sure I had M6, but
Oh, it's because when
this is
you when you
yeah, yeah.
because the scroll wheel. Yeah,
Oh,
yeah.
oh, this is, I need to disable that. I need to disable that because yeah.
By the way, can you mute your stream volume thing, whatever it is called?
Sorry, is that noise? Hold on, let me mute it.
Yeah, like your the YouTube audio was coming through. Nothing else. That's it.
Oh, okay, okay. Um, let me just. All right, give me a minute. Let me just.
Even after going through the entire course, I might just like go through a standard SolidWorks course once again.
Or what?
Even after going through this entire course, I might just go through like some generic SolidWorks course once again, because a lot of concepts are rust here.
Yeah.
Like I have
Approximate
no.
locations that
Yeah. Okay, yeah, this is what you were talking about, where you have to like move defense contractor. Damn, I'm trying to get to Texas. This guy need to refer me. Uh, all right. System.
Oh.
I really don't like the fact that you can scroll on top of these things. I think.
Yeah. Yeah, yeah.
Well, I guess to straighten them.
Yeah, just specify the dimensions of where they should be.
Yep. Sure. Oh, no, it's not here. It's smart dimension. Oh, in the video, I guess they removed it. Oh. Let's see. Let me switch the volume up a little bit. I just want to hear what they say at this part.
Yeah.
Poles, which is determined by their center points. Right-click on it and select the first icon to edit it. Select the top view from the heads-up toolbar.
Yeah, Tanya, on your
Yep.
Discord stream, there's an option to not like not
Oh,
route your stream audio, so you could have that
actually,
playing.
that's what I was trying to look for.
Yeah,
Let me see.
I was trying to look for it as well, if like I could do it through mod access, but I don't think I can. Can I?
Oh, mod access? Maybe.
Wait. Let me try sharing my own screen. That way, I, I can get an idea of it. Oh yeah.
Okay.
So once you click on the three dots, you have an option to
Yep.
share stream audio. Just uncheck that.
I don't think I have that. Man, do I need like mod access for that?
No. I mean, if it's not
Is
like
that
if you're not able to do it,
previews?
then it's fine too, I guess.
I guess I have my voice settings here. Just
Wait, can you speak now? Just for a
yeah.
sec. Yeah. So I think I did that. So I think it should be fine now.
Okay. Because I definitely do not have that option on my three dots.
Yeah, I don't know. It could be a
Okay,
weird
well,
Discord thing.
I can try. Can you
And
hear?
click on Smart Dimension.
I mean, I can still hear, but doesn't matter that much.
Oh, yeah, no, it's weird because I definitely do not have it. Like, I try to check from here.
No, it's like hover over your stream.
Sorry?
Like it's the
Oh,
three
here.
dots. Yeah,
Share stream audio. Okay. All
that
right.
was
Well,
it.
okay. Let me try.
Find the two locations.
No.
Click on the first point.
Okay.
Still?
That did not make any difference. Yeah, I guess leave it.
Oh man. That is
Don't spend too
weird.
much time on it.
Okay, no, I just thought that would be
I
alright.
did
Well,
too.
well, maybe we need to report a problem then. There's a problem with this.
We'll create another issue on Discord, GitHub.
Yeah. Oh,
It's
well,
so
okay.
weird.
Well, okay. Let's...
We are aspiring to be robotics engineers and we can't figure out Discord.
um, Okay, wow, yeah. No. Okay, selected entities.
C channel.
What'd you say?
I think what? Okay.
Oh, wow. Okay, 12.7. Yes. Stay smart. I guess 12.72. All right. Oh, why like this? Okay. I guess I have it unlocked now. However, connect. I guess 95.4. This gets centralized, but oh well, that's already. Oh, that's something.
Components that order is created. Sorry, did you say anything? I don't remember.
Could you still hear me?
No.
No.
I mean, I can hear you, but not the video, if that's what you're talking about.
Oh no, I'm not playing the video.
Oh,
I'm not playing any video. I was just asking right now about your how your driving tests went.
it wasn't like an actual driving test. It was,
Oh,
uh, yeah, the
the
written
written
exam.
one?
Yeah.
Ah, okay.
It's fine.
I thought you were talking about the practice.
I mean, there's a really
Oh,
nice story around it too, but I
oh
think
really?
I don't know if I should distract you right now. It's mostly a rant.
Oh, really?
Yeah.
Did he not go the way you planned to?
Well,
Okay, maybe
is
then
it
you can save it for later.
is it immoral to roast your own government on stream?
No, I I did it not long ago, so
Well, basically, the the office that they had the test on was about let's say 55 kilometers from my home. And when I
oh
got there, like okay, so first of all, like I had the option to conduct the test online, so I tried that, but for some reason that did not work. For some reason it wasn't able to recognize my face, and it asked me to give the exam at the office itself. Now, uh, now upon reaching the office, uh, like apart from the delay, even after going when I finally got to the like testing area where they had a computer that we had to give the test on, uh, the the supervisor that was guiding me, he wrote down in my form, he wrote down pin and then a number. So when I entered that pin, it did not work. So I got back to him. I was saying, sir, that this I am unable to do it. So he yelled at me, and he basically told me that, dumbass, you you do not know the difference between a pin and a password. I'm like, how are a pin and a password different? How am I supposed to know that? Okay, got it. Let's assume a pin and a password are different. So I entered the pin and the password separately. I supposedly the password was to come to my phone automatically. It did not. I regenerated the password, did all this weird bullshit, and finally, after entering everything, uh, it still had this weird error. I have no idea what the error was, neither did the instructor. So, after spending almost 2 to 3 hours at the office, nothing worked. Another day wasted. And yeah, it took two trips
since
to the office for this like 5 minute test.
this is ridiculous.
Yeah. And they wonder why there is so much corruption in India. Why half of the people don't even have a legit license. They just pay up driving instructors and they make it. Same with the pollution certificate as well.
And
Like in India, it's mandatory for every motor vehicle to have a pollution test done every 6 months. But the pollution testing guy does not even have a machine to test pollution. He just checks your number plate and enters random values.
this is bad. This is bad. Cause how? Nah, it's definitely. Man, I'm not gonna lie to you. Like I see so many like videos of driving in India. I'm not gonna lie, it looks scary.
It is.
Oh, No offense though, but it looks really scary.
I mean, where my home is located, recently there was an incident where like two children and an adult were sitting inside a shop. Mind me, they were just
Oh no.
sitting inside a shop, and then
Oh no.
like a tractor like just
Oh
whooped
no.
into it.
Oh no.
I think one
Oh
of them
my
did not
gosh.
make it.
Oh, that's awful.
Yeah.
Yeah.
Like
Oh.
of course it depends from like the region to region because you cannot think of India as like one
Oh
big
no,
country.
definitely, yeah. Yeah, definitely, definitely. I'm aware of
Yeah,
that.
it's way
It's
too
just stories like
diverse.
that, regardless of where it is, this is not good. Like, this
Yeah.
shouldn't be.
Like I'm aware that a lot of people in South India do drive really well, but in the
Hmm.
North, nah, not really.
It shouldn't be though. But yeah, I agree. Even for me, like, I mean, I'm not from the US. I'm originally West African, so
Oh,
our country, yeah, I'm not from the US. I'm West African from a small country called Benin.
uh,
Yeah, it's a very small
called,
country, about Benin, Benin. It's about 12 to 13 million people. Very, very small.
oh,
Yeah,
oh, it's close to Nigeria and Ghana as
yeah.
well. Oh, we do have someone
Yeah.
from Ghana.
Oh, really?
Yeah.
Yeah, to be fair, I definitely did my undergraduate in Ghana, and
Oh,
yeah, and I had like three Indian professors. I think there's a good relationship with Ghana.
I mean, yeah. There's like
Like
an
I definitely
exchange
had,
program as well.
yes, yes, had three professors in EC from India.
Oh, that's cool.
Yep.
In this city that I am studying right now, I have seen a lot of like African exchange students quite recently.
Yeah, yeah. I'm not surprised.
So when did you move to the US? Do you have like permanent residency here?
Yeah. So I moved in 2022.
Hmm.
Yeah, with the residency. Well, we had the green card program, but to be honest, it was luck. So then I was selected, and then from there I just came in. Though my like story is a bit different, because before this I was going to settle in Canada. I had
Hmm.
like a scholarship. That's why I did my master's. I had already finished my internship over there. And in the middle of doing that, I got the opportunity for the US. I'm like, yep, I have to take it.
Yeah.
So I took I took it, and well, I came in and been trying to. I've been at it since. Yeah, I've been here since 2022, and yeah, it's. I just feel like it's been a lot. I feel like it's. I jumped into a job too fast, but at the same time, I didn't have a lot of time. Like on my own, I don't really have a lot of family here that would support me and stuff like that.
Hmm.
So it's pretty difficult to say that, oh, I'm waiting for the perfect opportunity. I had a lot of interviews back then. The market was definitely different than what it is today,
Yeah.
to be honest. I was talking to a lot of companies now, and now it feels like you really, really have to. I don't even know. Like the market is so competitive today. Relations.
I want to know what kind of roles companies like Festo have. Do they have specific R&D roles, the people who make the initial prototypes?
Um,
Like similar to the
well,
role.
what's the name again? Festo?
Yeah, the one that made the
What was the
robotic
name?
kangaroo.
Festo?
Yeah,
This
yeah,
is it, right?
Festo. Yeah, wait a sec.
Well, what were they?
Yeah,
Well, they definitely have an R&D. So, well, it would definitely be uh, virtual teaching. No, they just talked about what they do. I'm pretty sure they do like most companies. They would take graduate student interns to do research for them. That's really why I want to get back into a graduate program. Like a lot of the companies would take graduate like masters, PhD students. Wait, where is their careers page? I mean, most pages have it pretty. It's pretty straightforward for most pages. Okay, R&D. Yeah, just like I say,
mechatronic.
intern is it's usually yeah, it's usually internships. Let me see what this role has.
Yeah, I'm really curious about that. What do they even
Sorry?
do? Like, I'm really curious what an even like what an R&D intern even does.
Yeah, that's what we're about to find out.
I mean, the
Wow.
experience required is well, 5 to 10 years
I
minimum
mean, oh, you want to do
experience,
the
bro.
for an internship? Oh no, no, hold on. Sorry,
Oh, this
sorry.
is
This is like
yeah.
the actual role. This is the actual role. My bad, my bad. Let me open the internship. page.
I mean, we
Internship
aren't too
page is
far away.
less, yes. Alright. CAD, okay.
Bachelor's or master's.
That seems fair enough for this role, to be fair.
Yeah.
And then duties, you have to design. Obviously, you'll be doing a lot of CAD testing, yes. R&D, yes. Support. Yep, that seems about right. Like, let me show you an example. I think on the alright. And most of these companies, to be fair, like I don't know, it took me a while to realize, but that's what they do. You have to get into them via internships. So they do self-driving,
You work here,
mass
right?
intelligence. Yeah. Not at the research institute, but at the R&D. So the research institute is like different from it. It's still, I guess it's still under the same ownership, but pretty different. So you have intelligence, robotic research, and then robotics itself. I guess the robotics itself, it's let me see the related projects. Well, yeah, deep tactile experience manipulation. This is a hot topic. This is what I'm doing.
Hmm.
Motion planning and decision making. Uh, Perception of mobile robots in crowd. Human robot. This is another hot topic today. Yeah. So this is mostly by this was with 2023. See, this is why these people need. If I get internship here now, there's a lot that happened between 2022 and now.
Yeah.
But yeah, like if you go careers, I guess intelligent, this is probably where they do more of the recent research. Dexterous, multi-fingered. This is what so many.
This is cool.
I saw a paper on this thing recently, but uh, this one manipulation,
Yeah,
like
that is
no, sorry,
some.
the yeah, dexterous, multi-fingered.
Yeah.
Yeah,
That might be something I'm interested in because
yeah.
it
So
uses the biomechanical concepts.
mm, yeah, more into the bio thing. Okay, well, we should go. For example, they have contract position associate. Oh, they even have that. This word is very, very redundant nowadays in the job. Deployment engineer, deployment this, deployment that. And I've learned that, I mean, in terms of coding, Industry does a lot more C++ than Python. Yeah, I mean, I definitely looked at this page before, but that's like minimum PhD, minimum PhD, same PhD, PhD. Yeah, yeah, I said it. PhD.
Okay, so if
Okay,
you
well,
will join a lab as a wait,
hmm?
if you join a lab as a student, then uh, will you get your PhD there?
Well, if you want to. So it depends on if your PI can secure funding
Like, what's your
or the
plan?
number of years that I. Oh, my plan. Oh, you're asking about me specifically?
Yeah.
Yeah, so I'm trying to join a lab now, and then I mean, obviously, apply for a PhD at the same time.
Hmm.
So I'm looking for a professor who can secure at least 4 years of funding, so I can assist him and support his research.
Yeah.
And I will be targeting like internship positions like these ones. And the thing is, from what I've like from all my interactions, like I've spoken to so many people, I have so many friends that are currently doing their PhDs. The PhD is not about the school that you go to, it's more who you're working with. Like
Hmm.
this Honda Research Institute, so many professors in like some of some schools in California have their like they have contacts there, right? And also like if you look at OSU, this is the university where I am like in my city right now. I think it's a pretty big research university. A lot of professors here have contacts here, for example, at
Wo-
HRI. So it's all a matter of like I mean I guess to answer your question, yes, I would get into a lab and do a PhD, try to get internship positions like these ones, build connections. I want to at least explore 2 or 3 different industry labs
Yeah.
just to really see what I want to do. For example, okay, look at that one. Call for University Projects 2026. So this is like a typical thing of what I want to do. Like once I get into this into a PhD program, then I start applying for internships like these ones, right? So this project is particularly on what you just said that you're interested in, like the dexterous hand. So they want like, I guess they have secured funding for it, and they're looking for interns. So yep, if I was accepted into a school now, I could have applied to this one. I mean, I guess no, this one already passed, but this is the typical thing that I want to be doing.
Hmm.
Yep.
Do you have a particular
Um,
school in plan to
yeah.
apply?
Yep. I have a list actually.
Oh.
Yeah, I have. No, sorry. This is I'm trying to research. Yeah, this is one of the top robotics lab. This is really, really, really competitive. As
तब
a
तो yeah.
when you talk about robotics, yep. So yeah, to answer your question, yes, I have a list. I kind of diverted from the drawing, but I think it's okay. I think I can make my way all the way to like assembly, and then maybe we continue together. But let me pull up my list.
I mean, for the assembly part, we need some ready-made models, which I am simultaneously trying to find.
Yeah, I agree.
Physical frame assemblies.
So obviously there is the school that I told you about, OSU. This is one. Hold on, let me just pull all my documents. Work at any. So I rather pull like professors' pages. You must. Okay. This is one professors that I have on my list. The human-centered robotics lab. But I guess like from the school, UMass, that's like University of Massachusetts in Boston. Research, lifelong autonomy, which aligns, yep. Resilient autonomy, yeah. Something like that. So this project, for example, it touches path planning, decision making, manipulation, dynamic, I guess, collision avoidance. Then this, I guess, I haven't read any paper on this, but I'm sure this is like some auction-based algorithm for detection for decision making. So basically, when you have your three robots, how do you decide which one takes which package, right? So you have some
Yeah.
algorithms to be able to solve that for you. One of them is like it's called auction based, where basically you bid. But here I can see from the video that the robots are not of the same size. So here immediately it makes me think about like capability, right? So we know that the robot on the right has a bigger capability. So if the task is to pick up the biggest package, this is pretty straightforward. The biggest one is gonna take the task, right?
Yeah.
So this would probably be straightforward, and then I guess the auction based comes in with the rest. Maybe let me pull it up, put it back to the beginning. Okay, so there's one big package and another small one. Yeah, so just like I guess the biggest one automatically has to go with the biggest robot. So this is not even any algorithm. I guess it's like known capability of your robot. So you know the size of your robot. So you're able to immediately assign that. And I guess at this point they are doing what up. Probably need to read that paper. Maybe we can dissect that paper. I think this will be interesting to people. I think we can dissect that paper together. So here I can see that once, oh, this is too fast. Hold on. So once you have these two robots that have their packages, what happens is that I guess they have to plan their part. So they have to plan in a way that they do not collide. So here you have another algorithm coming in. So that's the joint prediction and planning. So each robot knows the position of the other robot, and they know, okay, each robot has to communicate where they want to go. And based on where each robot is going, the other robot needs to decide on where they want to go. So this is the concept of game theory. I mean, they might have used
Oh,
some other concept. Have you heard that before?
yes, I have heard about it,
So yeah,
and I
so
have
they
heard
might
people
have used
crying
some other
about it.
concept. Yeah, it's not easy, obviously. It sounds like game, but it's definitely not easy. um, yeah, so the concept of game theory is where one robot or multiple robot communicates where they want to go, and the other robot need to find a way to collaboratively um, go around without colliding.
And it
This
makes
is the type
sense,
of
like the situation makes sense when you have some sort of a central controller that observes everything, but it just starts to
yeah,
break apart when
yeah.
like everything is independent or you have like an unlimited number of robots.
That is where fleets come in. So you have the robot operate in fleet. So you definitely have a control. So they are all connected by a network,
Oh,
like an internal network, like a local network. Yeah. So that's why I think someone mentioned before that you also need some fundamentals of networking to be able to work in some areas of robotics, which fortunately I have touched before. So while doing my transition, I realized that networking that I've done for quite a bit is also into robotics, which is pretty nice. So
yeah,
yeah, to answer your question, they are not independent. They are all communicating through a shared network,
yeah, that does
and
make
that is
sense.
how. Yes, so that they are in fleets, right? So you could have this area as one fleet and a different area as a different fleet. So whatever happens here is like all robots are connected. Mind you, this robot right here has information of the two other robots, and that is why that robot is now moving because know that there's nothing for him to do at this point. So that is
Oh,
why, yeah. So they are all communicating. Um, per my guess, this is game theory being done right now. Them guessing that figuring out their own paths, um, and then repeating basically. So after a while, I would even say that these three arm robots are communicating to the network. So I think it's safe to say to make that assumption because this is the one that has to say that okay, I have a package, so I need someone to come and pick up my package, right? So I think we could maybe dissect this paper.
yeah, we could. I want to see you dissect a paper live.
Or live, like okay, well, I would definitely be up to the task. Like I want to do that.
Can we
I want
plan
to
it
do
like
that. Like
maybe uh 2.5 weeks from now? Because you
yeah,
have like some work in
Yeah,
between,
yeah,
right?
yeah. I need to. This is the paper, I think. Oh, this is ongoing. Oh, this will be fun to work on. Heterogeneous multi-robot. You see, I'm glad you made me open this page again because I just have him in my list and it's just slipping there in my short list. But I need to find the paper though. Heterogeneous. Let me see the name. Collaborative scheduling with dynamic sub. So yeah, I spoke about scheduling. So every robot needs to. Okay, let's read here.
I'm just gonna make another thread for like stream ideas. I'll definitely forget about it in less than 48 hours.
It is also advantageous to wait for teammates. Yeah, this is what I was talking about regarding this one. It is advantageous for robots to wait for teammates and tasks to become available. Exactly. In order to perform better sub-teams and reduce overall completion time. Exactly. So we introduce a new graph again, approach that formulates heterogeneous collaborative scheduling, yes, as a bipartite matching problem that maximizes a reward matrix. Okay. Learn via imitation learning. Oh, okay. Well, imitation learning, I was not aware that was happening in this scenario. So I'm curious to learn how. I was thinking this was done by optimization, like task allocation algorithm. But I like imitation learning approach. I think that would be a good project to learn about and see maybe why not try to have okay. Well,
Huh?
I didn't watch far enough. I did this is some collaborative task. I did not watch far enough. Now, how they able to do that, I need to learn. I need to work to read that paper now. No, because I did not watch far enough. Like I'm pretty confident I can explain what is happening all the way to here, but here I have no clue what is happening.
We could just do a stream called Robotics Reacts. You just you
Yeah,
just play a
yeah,
video and just start explaining things and just get blown away
yeah.
midway.
To be fair, yeah. To be fair, that would not be bad. That would not be bad at all. I I unfortunately have to drop off soon, but I would definitely be interested in um, trying to dissect this stuff tuning. I think this is the one. No, let me see. This was in 2024. That must be the one. 2024. Did you just create React?
Yeah.
Hi, my name is Williard Joshua Jose, and I'm a PhD student at the University of Massachusetts Amherst. I'm here to present our work, Learning for Dynamic Subteaming and Voluntary Waiting to heterogeneous multi-robot collaborative scheduling.
This man is trying to make us watch his video by force. I cannot scroll.
Ah.
Okay, well, I guess we have to watch his video then.
Collaborative scheduling to assign robots to tasks across different pixels in order to complete all the tasks. This problem is applicable to many different real-world scenarios involving multiple autonomous robots, such as agricultural robots in farming, space robots in extraterrestrial exploration, manufacturing.
They are using the mass of the package, like the weight. This is now okay. It makes sense now, but I still want to know how they figured that they had to collaborate.
Even the manipulators are different.
This formulation allows us to consider human-robot teaming by incorporating robots with their own capabilities. There are three main categories of solutions in previous works to collaborative scheduling problems. Heuristic-based methods and classical solutions. Although they run reasonably fast, they may not always result in optimal solutions. Integer linear programming-based methods provide optimal results, but may not necessarily run in real time for a larger number of tasks and robots. Recently, there are previous learning-based methods that show promising results that can balance runtime execution and real-time performance. However, they do not address cases with high payload tasks that require robot sub-teaming and cases where opportunistic waiting for other robots can improve scheduling quality.
So that's the sub teaming that they're trying to solve, right?
Graph learning
Mm.
introducing graph attention transformer network that computes rewards for scheduling tasks to robots, and we consider both dynamic sub-teaming and voluntary waiting, resulting in higher quality solutions. Our approach is called learning for voluntary waiting and sub-teaming, or LVWS. We represent robots as nodes in a graph, where each edge can encode relationships between robots, such as communication reachability or spatial positions. In this paper, we assume a fully connected graph, indicating that all robots have full visibility of one another. We represent the tasks as nodes in a directed acyclic graph, or DAG, where each directed edge represents the task dependencies. We formulate collaborative scheduling as a bipartite matching problem where robots are assigned the tasks. Then, we input these graphs into a graph attention transformer network that integrates graph attention networks to encode the local graph structure and transformers to encode contextual graph information. The resulting outputs are embeddings for each node as well as a global embedding for each graph. We utilize these embeddings to compute a reward matrix used to perform bipartite matching. The reward matrix has size n by n plus 1, where n is the number of robots and m is the number of tasks. We allow dynamic subteaming by relaxing the requirement of one-to-one correspondence in classic bipartite matching to allow a single task to be scheduled to one of the tasks or robots. At the same time, the n plus 1 column is used to introduce an idle task that can be selected for each robot to wait without performing other tasks. We learned this reward matrix in our models using imitation learning, where the proper reward is determined by an expert system implemented by dynamic programming to achieve optimal scheduling. Although the expert system solution is exact, cannot in real time and is orders of magnitude slower than our method. We demonstrate our method in a manufacturing assembly case study run in a gazebo simulation. There are 3 robot manipulators in 3 assembly cells, and there are also 3 ground vehicles with different payload capacities. The manufacturing process is decomposed into 14 tasks with varying capability and payload requirements. We can see one of the Jackal robots demonstrating voluntary waiting at the start, and we can also see the Husky, the Jackal robot, has formed a sub-team to transport an oversized payload. These robots are autonomously operating according to the multi-robot task scheduling solution that was computed by LVWS. For this specific case study, the solution by LVWS is also the exact solution. We can also demonstrate our method running on real-world robots. We have two human workers in assembly cells replacing the robot manipulators, and we have the same three ground vehicles. The simplified manufacturing process here is decomposed into 7 tasks, and we also observed one of the jackals at the start demonstrating voluntary waiting. The two jackals here also successfully transported an oversized payload by forming a subteam. The robots here are being teleoperated, but still according to the scheduling solution by LVWS, which is also the optimal solution for this case. Finally, here we show our quantitative results. The metric make span is defined as the total time to complete all tasks. The left table uses the metric suboptimality, which measures how worse a solution's make span is compared to the exact solution. Our method outperforms all 4 baselines on 2 datasets. The right table illustrates our method's scalability with larger numbers of tasks, where an exact solution is intractable, and we also see our method outperforms the baselines. Further details are available on the paper in the Tower Posters session tomorrow. In summary, we proposed a new deep graph learning method for collaborative scheduling. We also introduced a graph attention transformer network that computes rewards for scheduling tasks to robots. Finally, our formulation considers dynamic subteaming and voluntary waiting to reduce the overall task completion. Thank you all for listening to our presentation.
All right. Well, that was interesting. Yeah, so this is gonna be the paper. I think it will, so okay, well, what did you think of the video? Of the presentation?
Hmm. No subteaming, no derivating.
Sorry?
I did get the gist of the video, but
Yeah.
there is still a lot to break down.
Yeah.
We might not even make it in a single stream. We might need like
Oh
3 or 4
no.
consecutive streams.
Yeah. I think, yeah. Because if I have to read this paper, I think I will have to read it at least 4 times before I can start to understand. But because it is like something that I actually have like basic knowledge on, like I know some of the task allocation algorithms and stuff like that. This is a typical thing that you would do if you do robotics in like in a factory or something like that. If you're a robotics engineer in a factory that is especially that does autonomous robotics, this is the type of things that you need to be learning. And I guess this is where my interest is, I guess, in terms of robotics. All right, I think I'm gonna have to unfortunately head out soon. Um, I have to finish up a couple of things, so I'll be dropping off the call soon.
Yeah. I am
All right, man.
still
Sorry?
I'm still like unable to find the parts that are in the assembly lesson, like the C channel.
Oh yeah.
It's gonna take a while of searching.
Yeah. Yeah, we'll see. I'll try and do some research on my end too.
Yeah.
I think this new channel that you created, like we could also be doing like doing some solving some optimization problems
Yeah.
or like some DSA.
Like in what channel? Like in your channel or like the default channel we are streaming in right now?
Oh, the default channel. Default channel. I would definitely be doing my own like solving problems and stuff like that. But yeah, we'll coordinate that.
Solving optimization problem sounds fun, but DSA.
Yeah, I mean,
For a live stream, it might
no, but
become.
like,
If it's in specific
yeah,
robotics context, then it would make sense.
yeah, for
Which
sure.
is something I have been unable to find out anywhere on the internet. Especially like I haven't found a particular course or article or a set of questions for like DSA for robotics kind of thing. I have searched a lot, but there
Yeah,
are literally no results.
yeah. Now the closest you get is like machine learning for robotics, and
Uh,
that's where you find like problems. I mean, well, I gotta leave now. I'll
yeah,
catch up hopefully tomorrow.
yeah, sure.
Yeah, have a good one, man.
Bye. चादरों के सिमटे तुझे भी बुला रही है जाओ दूर इनसे कहे सुकून कहाँ पे है आपसे दिल को मेरे ये है पता कि मीलों का ये फासला है. Hopefully the stream did not end. अलग आसमां भी है तो क्या कि दिल लमाने ये गाड़ियों की ऐसी दौड़ सा तेरा भी दिल दौड़ता है जा रहे हो दूर तुम तो क्या मैं ही वो दिल का मुसाफिर तो एक बार फिर हंस के जरा देख ले मेरी इन आँखों में मैं कैद कर लूँ हर वो पल तेरा तेरी ये बातें जो हैं तो और क्या है ये बातें बता क्यों हर दिन डरता नहीं बिना तो ऊ, 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 Now, where the hell do I find the C channel? Bum, 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 bum. Assemblies and welded. Uh, different sets of mates. Uh, hmm. 37 millimeters. That's like 0.3 meter. Mean, hopefully. I guess we'll see about that. This does not look the same though. How many members do we have? 125. So 123 and my alt account and another bot. Nice. गोल क्यों है ज़मीं सोचा है इतना कभी outer C channel SDL part SDL part क्यों है ज़मीं By the way, if anyone is curious and if anyone thinks that I'm taking a break right now, for the last about 25 minutes, I've been trying to find what's called a C channel, which is supposedly required for the tutorial, and the links that they have provided do not work anymore. Why? Learning resources. This link does not even exist anymore. What if I 9931 ENU? Uh, 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 SolidWorks resources, resource center. Uh, Mm, resources. What's it even called? Resource types. What is that? I think I got it. Was this unit 3? It was unit 3. So open. Ooh. Wayback Machine is so cool. It's been 2 hours. Does not feel like it. It honestly does not feel like it given the amount of progress I have made. Mm. Mhm. 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 Countersink dynamo windmill wiring arm wing arm? Nee. Nee. This ain't it. This ain't it. So maybe it's listen to assemblies. That would make a lot more sense. Gonna kill SME. Still does not make too much sense though. I mean, whatever. Let's just see if we can. It's gonna take a while. 2011. Oh wait, 2025, 11 years from now would be 2015. Oh, whoa. Unit 3 assembly. Lesson 1 assembly project. गली में मारे फेरे पास आने को मेरे गली में मारे फेरे पास आने को मेरे कभी पलकता न मिले तो कभी पलकता छोड़ पलकता न मिले तो कभी पलकता छोड़ अंबर सरेगा मुड़े आवे कचिया कलिया ना फूल तेरी माने बोले मुझे मीठे से बोल अंबर सरिया आ got it. Huh? Browse through these two. Yeah, guess so. I guess so. Mm. सिर में तू जाए निकल गई सीधा एक दिन कभी जो खुद को तराशे तेरी नजर में मेरी नजर में तू जरा आए रे आँखों में तेरे क्या क्या छिपा है तुझको पुकारूं मैं जरा आए रे एक अनकही सी दास्तां ऐसे समय आ जाए ना Okay. Solid, SolidWorks, SolidWorks Design. So the assembly depicts the oh, or outer and short, I suppose. Yeah. A fellow member needs help installing ROS. I mean, you kinda have to go through the pain. That's how you learn. That's how you learn installing ROS by installing ROS for the millionth time. It's fine, he'll get it. Ooh, yeah. Yeah. I'm just gonna drag it to another monitor. Don't want copyright, do we? What does configuration even mean? Okay. Utte. Is desktop audio on? Is it? No, it's not. It's lowered though. And it's kinda audible, but I don't wanna get it too audible because then like I'll probably get a copyright from automated copyright strikes. The thing is, I don't need to change the SSH key. What?
Whack, whack.
Mate. Uh, mate. Mate. Mates that we'll use later. What the fuck? Wait, 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 wait. Huh? Why am I unable to select the plane? Oh, okay. Sure. Yeah. Then this face as well. Yeah. Jaw. Jaw. Bro. Bro, wait.
Two entities to me.
Okay. Mate selection. First of all, this is the most visible, I guess. So, in order to mate, in order to mate, order to. Uh, yeah. Why is that so funny? Is there a certain distance or angle? Parallel. Okay. They are not in the same plane right now. That does not even remotely look like the same plane. Uh,
Relatively a coincidence.
How else? But I did just use coincident, didn't I? Yes, I did. That does not make any freaking sense. 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 Bruh, where are you flying off to? Bruh. That does not look like the same plane, lady. Like even in the tutorial, it does not look like the same plane. It looks closer to it in comparison to parallel, but still not the same plane. Bep. Then what? Can I select it using the workspace? Probably can't. I just have to use this. And it just shoots forward. Yeah, 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 yeah. That does not make any sense. What even is that? I mean, yeah, sure. Yes, definitely. Yeah. Oh, wait. Maybe it is the same plane. It could be the same plane. But how do I change the physical distance between them? Oh, wait. Maybe I do get it. Oh no, I don't get it. I seriously don't get it. Uh,
You need to select the two entities to mate, which you can do directly from them. First, you need to select the
Okay. So I think I have done like a big brain trick right now. I got through the video frame by frame to find out the exact face she selected, and it's boss extrude 1 of outer C channel 1. So what I'm gonna do is go to mate, is in this tab, just gonna find extrude, okay, outer channel, annotation solid bodies, extrude 1. Oh shit, no. Hey, 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 front plane, top plane, wrist plane. Let's try the wrist plane. And this. The heck? Why does this work? Okay, so this works. Somehow this works. But if I try the same, with, yeah, let's try it with this face and the top plane of that. That just goes zoomies. Why? Why? We'll deal with it later.
mate, which you can do directly from the workspace, or from the feature manager, which is now shifted on the screen. Notice how the underdefined part moves so that the two planar faces satisfy the constraint imposed by the mate. Coincident, which means they are in the same plane, parallel or perpendicular, or at a certain distance or angle. You can also flip the measurement direction or the alignment of the mate. The concentric mate is usually used with arcs and circles, and makes them have the same center or axis, while the tangent mate is used between curves or the concentric mate is usually used with arcs and circles, and makes them have the same center or axis, while the tangent mate is used between curves or circular surfaces and lines or planar surfaces. To edit or delete a mate, expand the mates folder in the feature manager and right-click.
Oh.
Let's now start our robot base. Click mate and select the U face of the
Okay, I'll complete the rest of stream. I gotta go. I woke up at 4 and I haven't had breakfast yet, so bye bye.